Hey, I'm Evan, Head of Engineering for RMSTATOR. We're going to take a look at our new sales sample case. So this is a case that we're putting together to provide you with some of our top selling products and technology to let you show your customers and get a good feel for the different product offering that we have. Comes in a nice waterproof carrying case like you can see here. The color may differ on the final versions, but this is our early version. So you open it up here, it has foam cutouts with the different parts inside. And so we're going to step through them, look at each part, and we're going to discuss some of our technology and features that go along with each of these product lines. So let's get into it. Okay, we're going to take a look at our stators and see the kinds of technology that we use in them. So the example we're going to use is our Polaris split stator. We call it split because it has two separate three-phase or three-wire windings wrapped on one stator core. This lets us split the output of the stator between two voltage regulators and then run that output back to the battery. This lowers the overhead on not only the stator windings but the regulators and makes for a huge increase in reliability. When paired with our high power flywheel, we can also get 250 watts of increased power. So from 650 watts to 900 watts using this stator and our flywheel. So not only is it an improvement as far as power output, but it's also a reliability improvement. As far as some of our stator technology I want to show you, the first is what we call our edge technology. So you can see here on the outside of the stator core is made up of lots of plates, these thin steel plates that are stamped out and riveted together. That makes up the core that the wire is wrapped around. So our edge technology uses extremely thin plates, and you can think about it like the radiator on your car. These thin plates and all this surface area helps pull heat away from the windings into the core and then dissipate it into the oil of the engine. So this can make a massive increase in the reliability of the stator windings. When you compare it to an OEM or other aftermarket stators, it's very easy to see just how thin our laminations are. So our edge technology is one of the best, and we use it on lots of stators in our range, especially our high power applications. We also use, many times we use metal wire clamps to hold the wire in place. There are some alternatives. We do use a cloth wrapping and even a plastic attachment on some applications, just depends. Especially large stators and high power applications, we typically use a metal clamp. We use OEM style rubber grommets that are a perfect match for the original and a perfect seal to your side case, so we don't have any oil leaking or water able to get into the cover. And then we use OEM style connectors. They're sealed, same locking attachment, everything you would see on an OEM connector. So this makes for a nice plug and play installation. We also increase the wire gauge many times, especially in high power applications. So we'll go up a size from the original. That helps keep heat down in the wiring harness. And we'll also often use this silicone insulation on the wires that makes for very good reliability of the wiring harness since it's impervious to heat and gas and oil and all sorts of stuff. So these are some of the features that we build into our stators. You'll see it across our whole line, and you can show these features to anybody to get a good idea of what we do different than the competition. Okay, we're going to take a look at our flywheels. This is our Polaris, what we call our split flywheel. This is our high output 900 watt flywheel. It fits the Polaris Razor, Ranger, and Sportsman's. So this is designed for use with our split system. That is a stator that has two outputs and uses two voltage regulators. This flywheel has high powered magnets and allows you to go up from 650 watts to 900 watts. So it's high output and high reliability. So not only is this a great application, it's also a great example of what we do with our flywheels. So we like to build some advanced features and technology into our flywheels to make sure they're the best on the market. Our flywheels are always completely capped. As you can see here, the magnets are covered. We use a high-grade epoxy to attach the magnets to our flywheel core. And we never have any failures of our epoxy, but OEMs are known for that type of failure where the magnets will come loose and hit the stator and damage things in your engine. So we don't have that problem to begin with, but just in case, we use a capping around our magnets to make sure if one ever did come loose, it could never completely come loose and hit your stator and cause other damage. Our flywheels are balanced after manufacturing, so they're perfectly balanced for your engine, just like an OEM. We use precision machine timing marks, just like the OEM, and a precision machined taper, and keyway, just like the OEM. So these are OEM installation, along with nice features like, in this case, high power magnets for high power application and capped magnets. So this is a really excellent product line. We have it available for all sorts of motorcycles and ATVs with these features included. We're going to take a look at our REVOLT regulator rectifier technology. So this right here is REVOLT. This is our in-house designed voltage regulator that we currently build here in Colorado, in the United States. This regulator was developed by myself and in partnership with the 3IT engineering department at Sherbrooke University in Quebec, Canada. So we designed our own circuit for the regulator and the rectifier, and this is currently the best regulator on the market, and I'm very happy to say that. We are currently patent pending on this design, and we'll talk a little bit about what it does. The REVOLT uses our what we call Rectifier technology. So what this does is we do not use any diodes in the rectifier portion of this regulator. And when we went to the drawing board and looked at why most voltage regulators fail, and we've been building them for years, so we have lots of data to look at, it is almost always 90% plus of the time it is a diode failure in the rectifier. So the rectifier is the portion of this unit that converts alternating current that your stator is producing into direct current that your battery can use. And it's a critical function of these units. However, those diodes generate tons of heat in normal use. So over the years, it's become common to see a MOSFET type regulator. That is a regulator that uses MOSFET or power transistors to do the rectifier work, which is a great upgrade. However, even those units still use diodes in the rectifier. So while that made a huge step forward, we wanted to completely solve the problem and not use any diodes in our rectifier. And that's what we've done with REVOLT. We have our own control circuit that we have designed that controls our power transistors to do all the rectification and regulation functions inside this unit. What that means is up to 50% cooler temperatures compared to OEM or the best aftermarket regulators on the market. In many situations, I can't say it for every single one, but it is a massive improvement where you could run a regulator, a typical MOSFET regulator on your bike. After 30 minutes of use, you could put your hand on it and it would be so hot you couldn't comfortably hold your hand there. In fact, it could even burn you. The REVOLT will be mildly warm to the touch. It really is that good. We designed our own housing for the REVOLT regulator. It is a billet aluminum CNC machined housing. You can see just how many cooling fins we built into it. It probably is overkill for the technology that we're using, but if we're going to design our own housing, we might as well make it cool as good as we possibly can. It's anodized black, so it looks really nice. It's the first regulator you actually want to mount somewhere on your bike that people can see, so I think that's awesome. We put it in a case that is compatible as a direct replacement for many of the OEM regulators, the Shindingen types that are used on many Japanese vehicles, and also many of the regulators used by Polaris and Can-Am BRP products. So that's nice because it'll fit in the OEM mounting location and on many, many vehicles. We also used this connector type that is becoming pretty much standardized in the industry now. You can see the gray connector that you've probably seen before. That is the stator input, and the black connector is the battery output. We also include mating connectors with each of these. So if your vehicle did not have this connector type, you can convert your wiring over so it'll plug right into the unit. The other thing that we do is include, at no cost, wiring harness adapters to make this a plug-and-play installation for many applications. So you can see here where we have an application that'll be popular to use REVOLT. We have the harness available. It'll plug right into the REVOLT and adapt it right over to your vehicle side connectors for both stator and regulator. So that makes for a really easy installation. So all that being said, REVOLT is the newest regulator technology on the market. I think it's the best on the market, and it is available for a huge range of applications as a plug-in and an easy conversion on your vehicle. So make sure you check out REVOLT and make sure you show your customers, because this is the future. Starting out some REVOLT comparison testing here in the Colorado mountains. and we're going to get started. We're running a Splyt system, our dual output stator prototype here on our Can-Am Maverick, a 2014. We've got one REVOLT regulator here for one output, and we're measuring temperature on top of the regulator housing with our thermocouple. And we have our comparison regulator here. This thing normally runs 2 REVOLTs down there, but we are running our comparisons up here that'll just be mounted here so we can swap them easily. So we're starting with the, this is the SH847, if you can see it there, Shindinjin, their largest case series regulator. This is typically the coolest running comparison regulator available OEM. So that's going to be our start. And let's come in here, take a look at our setup. I'll be taking some temperature measurements every couple minutes, and we'll put them together on video here so you can see. So here's what we're starting with. Our thermocouples aren't exact, but number one is our REVOLT, 26 degrees C, and we're comparing it to 29.9 C. Both of these are room temperature ready to go. All right, so we're gonna get started driving, have some fun, and we'll keep taking temperature measurements. And we'll do a bunch of different comparisons here. Here we go. All right, here's a couple minutes of idling. 26 degrees on the REVOLT, 31 on the Shindinjin series. So we're already seeing a split. All right, let's get started driving. All right, 5 minutes of driving. Still 29.5 on the REVOLT and 42.1 on the SH847. Keep going. All right. 5 more minutes, we're at 31.5 on the REVOLT, 46.6 on the Shindinjin. All right, here's another 10 minutes or so. We're at 34.6 on the REVOLT, 54.5 on the Shindinjin series. So we're seeing a good 20-degree split right now, and that'll keep going. We're going to take a look at CDI boxes. The part we have to show right here is our DC conversion, and we'll talk about what that is in a second. CDI box for the Kawasaki KLR 650, the 1987 to 2007 models. So this is a good example not only of what a typical CDI box might look like, but also we'll get into some of the special things that we do, like our DC conversion. So our CDI boxes are typically built to be a direct plug-and-play replacement for the original. We use the same connectors as the original. Depends on the application. Sometimes it's a direct replacement for the original timing curve. Sometimes it's an advanced timing curve or has a higher rev limiter. I can't speak for each one. There's a different design for each CDI box, and it depends on the application. So as far as OEMs go, we have them, and they're a direct plug-and-play replacement. Now, the special thing I like to talk about with our CDI boxes is our DC conversions. So this is something that we pioneered years ago, and we still roll out for new applications. What this means is when you have a CDI box that is powered directly off the stator on the vehicle, we call it AC powered right off a coil on the stator. That's great. It makes for a simple CDI, a simple ignition system. The problem is that coil on the stator can burn up and fail, and that will leave you stranded because you no longer have power to the CDI box. So for many applications, we build a DC conversion, and these are for bikes or ATVs that already have a good battery charging system. And so we reconfigure the CDI box to be powered directly off of the battery instead of the stator. That makes for a much more reliable ignition system. You also get some additional benefits, like I've seen cold starting be much easier. The motor, your spark is no longer dependent on RPM. As long as it's barely turning over, I've seen them spark as low as about 200 RPM. As long as the motor is turning over at all, you will trigger the CDI box and get a good spark since it is being powered directly from the battery. When you have an AC powered or stator powered ignition system, you are dependent on the flywheel spinning fast enough to generate enough power to therefore get a good spark. So cold starting is often an improvement, and I use these on my dirt bikes, and so I've seen much better improved hot starting, especially after like dumping a dirt bike and flooding the motor. So there's lots of improvements here. And this is just a good example of our DC CDI boxes. We use OEM plug and play connectors, so they plug right into the original harness. And then we have to power them off the battery, which wasn't originally true of the OEM CDI. So we try to include mating connectors or something that will plug right in line with a power source on the vehicle. So for this KLR example, this will plug right in line between the horn, which is mounted right next to the original CDI box. So it's a very easy installation. Another thing I want to talk about relating to our CDIs is we are the first company that has ever developed a CDI tester or CDI testing equipment. So what that lets us do is when we want to build a CDI box, we need to know exact timing curve of the original so we can either reproduce it or improve on it. We don't want to have or buy the vehicle for every single application we want to build a CDI. So we have designed and developed, along with the 3IT engineering department at Sherbrooke University in Quebec, Canada, we have developed our own CDI testing equipment. Now, this is hardware and software that we can hook up a CDI box to. We can simulate the pickup coil or the timing signal that the motor would produce, and we can power the box appropriately. And then we can capture back the timing curve that is being generated when the spark plug fires. And so when we can profile an original box and then we can build ours and compare the two, we can set our timing curves correctly, whether that's an exact match or an improvement. So we'll show some video clips describing that. You'll take a look at those and it'll help explain more about the technology. But this is what we use to develop both our AC and DC and conversion CDI boxes. So we're going to go ahead and start running our tests. So you'll see on the software here, we're going to start capturing the output of the box. At low RPM, we're at about 0 degrees. We're firing right at top dead center is what this is saying. And if you're looking over here on the oscilloscope, you can see the pickup coil pulse generating. So there is our trigger pulse being generated live. That's what's being sent into the CDI box. And we can see down here in the blue, the pulse of the CDI box firing to the ignition coil. So that's the ignition coil output. So if we watch our plot, you'll notice over here, our leading and trailing edge of our triggers are getting closer together. I'll zoom in a little bit. I'll leave it out. Okay, so you can see here they're getting closer together as the RPM picks up, and our ignition pulse is coming in as well. So now we can see we're at the part of the timing curve for this box right around 2200 RPM. It begins its advance, and we'll see where it ends up. I don't recall. Okay, about 22 degrees total advance at about 4,500 RPM. So that's great. We can stimulate the box just like we're using a motorcycle engine or ATV engine. We can create the right pulse to get the right timing curve out of it. And we can plot our timing curve all the way up to 10,000 RPM. So everything worked great there. So that's how our software is very easy to use, very easy to configure. We're able to easily test one of these CDI boxes. Now, what is very cool is let's look at some comparisons. So if I don't have a comparison saved, I think, for this CDI box. So, okay, we're not going to look at that. I'm going to go back to the main menu. Now, here's how we would use this software a lot of the time. Say we had just plotted, let's see, I'm going to say compare here. Say we had plotted an OEM curve from an OEM box and then our curve from our aftermarket RMSTATOR CDI box. So I'm going to go in here and open a test result for, here's one from an OEM box for our part number 02001. I'm going to open that. And then I'm going to open the second plot, which here's one I have saved for the same box, but our RMSTATOR version. So here we can overlap our two timing curves and take a look at them and see if our box matches or if we were trying to advance the timing further, and we can overlay the timing curves on top of each other to validate that. So if we're building an OEM replacement, we'd expect to see the exact same curve. If we're not, we would expect to see our different curve, but being able to overlay them is very useful. We can also zoom in by selecting here, and we can check that our advance happens at the same time, but we can see the exact difference in our data points, which is very useful. So we have really powerful plotting tools here as well. I'm gonna go back to the menu. Let's look at another comparison. So here's an OEM for our part number 2040, and here's our RMSTATOR. So we get the same thing. We see that we have a little bit more advance in ours as we had planned, but we see that our timing curves generally overlay correctly. So that says our advance curve is correct. Our software is very, very sensitive and very accurate. So you can see sometimes that we capture these drops here in the plot, and that could be a missed spark. It could be a lot of different things. It doesn't mean the box doesn't work or there's a problem, but our software is very sensitive to be able to capture this kind of stuff. We also can get some noise, especially at the low RPM simulations, where the motors are not typically running anyways. A lot of these boxes don't trigger well down at these super low RPMs. So we can get some junk data at the low spots as well. But what this is really crucial for is for looking at our overall timing curve and being able to compare them and see that they're different in the way that we want them to be or that they match correctly. So very powerful tool, really works well. We're going to talk about our voltage regulators and then even more specifically our billet CNC housing as well as our bypass regulators. So we've been building voltage regulators for years and we're good at it and we know them well. Our probably standard voltage regulator at this point is a MOSFET type circuit, and that means it uses power transistors inside for both regulation and rectification, though it does still use diodes in the rectifier as well. Our REVOLT technology is superior to that, but it is also more expensive. We also build many of our regulators in this housing and others with series regulation. So the difference with series regulation and this type A MOSFET regulator is that series regulation regulates by interrupting current flow from the stator through the regulator. There is series switches that will prevent current from flowing into the regulator from the stator. So that's how we're able to regulate voltage. They have a lot of benefits like being able to lower stator winding temperature and accurate regulation. They typically run cooler as well. However, MOSFET and shunt style regulators have been around much longer and they work very well with permanent magnet charging systems or systems that use magnets embedded in the flywheel. A shunt type regulator regulates by shunting current. So that means instead of passing it on to the battery, it is still, some current is still flowing from the stator and it is dissipated to the grounding of the heatsink, dissipated as heat. So the two different ways of regulating, both are good, both have their benefits, and both have their problems. And so we build all different styles for different applications. Many of our regulators come in an OEM type cast aluminum housing. That is the gray kind of rough looking housing that you've seen in many, many applications, and that works just fine. We also have our billet aluminum CNC machined housing, like I mentioned. So you get some improvements and some features with a billet aluminum housing. The cast aluminum housings, the gray housings that I was talking about, they have, they're cast, they're made from molten aluminum poured into a mold. The downside of that is they can be porous. You can have typically somewhat, not very rough to the feeling, but if you looked under a microscope or rougher surface, that can make for worse heat transfer between the circuit board inside and the housing to allow the housing to pull heat away from the electronics. The billet aluminum housing is made from a solid billet, solid block of aluminum, and then machined with a perfect surface. That makes for very nice heat transfer between the circuit board, the electronics, and the housing. So right there, you see an improvement in pulling heat away from the electronics. Not to mention, they just look nicer. We anodize these red. They look nice and they look great on just about any bike. And then we make them in a housing that will fit many, many applications in original mounting locations because of the slotted mounting holes in the sides. Okay, so that's a description of some of our different regulators and the technology, as well as some of our improvements to the housing. Now, what's special about this one? So this is what we call our bypass regulator technology. And we use that with both our series and our MOSFET circuits, depending on the application. And what bypass does is it bypasses connectors and wiring on the vehicle. So by the time you have an older ATV or older motorcycle, you can have significant resistance built up between the connections and wiring from the regulator to the battery. And what that does is that resistance between all that old wiring and connections can drop the voltage between the output of the regulator and the battery. So what we do is we bypass it. We make a regulator that plugs directly into the stator with OEM type connectors, just like this. And then instead of plugging into the vehicle's main harness and maybe jumping through feet and feet of wire and multiple old crusty connectors, we go direct to the battery terminals. So you can see here, we've got long wire that's the right length for the vehicle, and we have ring terminals on here to attach right to the battery terminals. So our bypass regulators are available for many applications, Polaris ATVs, Sportsman's, and other ATV models. And I'm trying to think, the Suzuki DRZ 400. This example is for the Honda VFR 800. We have them for Triumph, Daytona motorcycles, and others. So we try to apply this technology to vehicles that are known for that problem, and it makes for a massive improvement. I have seen the installation of a bypass regulator on many vehicles pull over 1 volt increase at idle alone. So just bypassing all that old wire and connections on the vehicle can instantly improve your charging system. So this is something you want to look for, and it is, like I said, made for many applications, and it's an excellent improvement. So we try to take that technology, apply it where it's needed, and we also try to add these technologies and features into all of our voltage regulators. Okay, we're going to talk about our Polaris Surepower ECM module we have right here. So this is an example of not only an ECM and an electronic control module, but also some of the other product types we do that are outside of just a typical stator or voltage regulator or even CDI box. So for Polaris applications, this was called the Surepower box, and it was used on many of their ATV and Ranger, I believe, applications. It combined a lot of features into one box. Not only was it the voltage regulator rectifier for the charging system, it also had circuit breakers inside to protect the electronics on the vehicle, and it controlled the cooling fan. So it had input from temperature sensor on the vehicle. So when you combine all these features into one unit, that may seem like a good idea at first, but if you have a failure of one function in the unit, the whole unit has to be replaced. We do make a bypass regulator for this application that lets you bypass the regulator inside of this. So if you did have a failed original regulator inside of this box, you could just bypass the regulator portion. So that's always an option. However, we wanted to build the entire module as a replacement as well. So people could replace this whole thing if they had their cooling fan control fail, circuit breaker fail, or voltage regulator fail. So not only do we use our MOSFET regulation circuit inside of this, which we've built for years, is really, really well developed and reliable. We use that inside, so it's an improvement over the original voltage regulator. We also have improved our housing over the original. We use a different cooling fin design that allows the regulator to stay much cooler and provide much longer life. We use OEM style wiring harnesses and connectors, so it's a direct plug into the original. You have your temperature sensor plug-in, you have your wiring harness plug-in for key switch, battery, and all that. And then you have your stator connector to bring stator power into the unit. So we are able to build a complete electronic control module for the Polaris that includes all the features of the original, but we improve it at the same time. So we're able to apply some of these ideas to other types of electronic control modules that we're constantly working on. So we have lots of new ones coming out, and we're looking at doing ECMs for ignition and fuel injection control and lots of other things in the future. So I think this is a great example of some of the innovative product line that we're adding. Okay, let's take a look at a different type of CDI box. This is our CDI for the Skidoo RER twin cylinder models. So this is the RER is the models with the ignition reverse system. And this is a unique one to look at because not only is it a CDI box, but it's the ignition coil as well. So you can see kind of the unique shape of this. The originals were manufactured by Ducati, and we're able to build an excellent replacement for those. We use an OEM style housing, OEM style connectors that are all plug and play, has the service plug as well, and has OEM style and length spark plug wires already attached. What is unique about this is not only is it the CDI unit, but it is the ignition coil as well, and it's a dual output ignition coil for the 2-cylinder configuration. So this is a really unique CDI. It also supports the RER functionality, which takes a button press from the handlebars and is able to stall the motor, kick the motor over backwards, and you're able to get reverse on the sled from the motor running. So this is a great example of other types of CDI technology that we build and other unique combinations having the coil and the CDI in one unit. Okay, let's take a look at a cap coil. So this is a nice example of some of our other product line, which is ignition coils. Kind of put it into this category. We do other things like starter solenoids, relays, key switches, wiring harnesses, lots of other smaller things. Our cap coils are excellent OEM replacements. They're made with the OEM style mating connectors, fully epoxy sealed to waterproof the coil inside. They're made with the OEM style and length housings, rubber grommets to seal into the cylinder correctly, and OEM style spark plug clips inside as well for a secure positive engagement to the spark plug. So these types of parts you want to be able to plug in, replace just like the original, and get back up and running. And we include all of these features and attention to detail in our coils, just like we do all of our other small replacement part product line, like our relays, solenoids, key switches, etc. Okay, thanks for taking a look at our RMSTATOR sales sample case. I hope you learned a lot looking at our different major product lines and the different types of products that we make, and learning about the features and the technology we use, as well as some of our test equipment and the attention to detail we put into our products. So make sure to check out rmstator.com. You can contact us through there, and thanks for watching.